everyone. In this video, I want to talk about uh, the way of measuring temperature and voltage using the XADC. XADC is a block that, as you can see in this figure, is located inside the PL section of the Zinc 7000 device, but it's also made accessible to the PS through dedicated interfaces. This allows the CPU to connect to the XADC and retrieve measurement data without requiring any additional logic implementation in the PL. In this experiment, the focus is on measuring the internal temperature and supply voltage sensors of the chip to examine the operation of the XADC and its voltage and temperature monitoring capabilities. We have three methods for using XADC for measuring and monitoring the temperature and voltage. In this example, in this video, I want to concentrate on the hardware-based, completely hardware-based design. The XADC block diagram is shown in this figure. As it is illustrated in this figure, this block diagram shows the internal structure of the XADC, which includes two 12-bit 1 megasample per second ADCs, ADC A and ADC B, external analog inputs via auxiliary channel, and the main differential inputs VP and VM, which are selected through multiplexer, the multiplexer that is available here, and routed to the ADC for conversion. The XADC also integrates an internal temperature and sensor, and also several on-chip supply voltage sensors such as VCC int, VCC auxiliary, and others for system health monitoring. As you could see in this picture, a built-in 1.25 volt reference ensures accurate and calibrated measurements. The converted data is stored in control and status registers, which can be accessed through the DRP interface. This DRP interface, or JTAG or FPGA interconnect, which enabling both the processor and PL logic to read and process the measurement result. As I highlighted earlier, in this video, I'm concentrating on method 1, which is hardware-based reading of XADC sensor data. For that, I have to connect the board to the PC and then go to Flow Navigator, open target, and auto connect it to the device that is already connected to the PC. I will show it in a practical manner. Okay, in the next step, I connect the board to the PC and then turn it on. Make a new project with the name of XADC test. And don't specify sources at this time. Board, Zibo board. And finish. Go to Flow Navigator and then open Hardware Manager. Open Target. Auto Connect. This is a device on a Zibo board, Z7010, and this is XADC. Right click on that, dashboard, and then new dashboard. Okay, name it whatever you want. For example, the default is dashboard underline 1. Okay, After that, the waveform window will be open, and with this option you could add selected sensor. As you could see, for example, we will have temperature, which is the internal on-chip temperature sensor, and it measured the FPGA die temperature. No external pins required for this one. The next one is auxiliary analog input channels of the XADC, differential inputs, auxiliary P and N, and it's used to measure external analog voltages. Voltage range typically between 0 to 1, depends on configuration. The next one is, for example, the VCC int, which is the internal core voltage of the FPGA logic, used for power monitoring and reliability. And this one is the supply voltage of the block RAM. VCC BRAM is the supply voltage of block RAM. And also this one is I/O bank voltage for DDR memory interface. And the others, for example, this one is dedicated analog input pins of XADC. If you want to monitor any of these, you have to click on them and select them. For example, the temperature has been selected here, and as you could see, the temperature of the device versus time is shown in this figure. Or if you want, you could also add other option like VCC BRAM, which is here, it is shown here, and with another axis, which is 0.995, and it has some overshoot, as you could see here, but the range is limited. It's not a lot, it's not a high. Okay, it's finished. In this video, I show you how you could monitor different temperature and voltages of the device via completely hardware-based design. In next video, I will show you the other methods that you could use for monitoring these temperature and voltages of the device.